Welcome back to the lectures in which we discuss the future of flight report from the Economist magazine. Until now, after a brief introduction, we discussed manufacturing and propulsion. And in this lecture, our aim is to discuss the innovations that are occurring in avionics. So let's click the link here to go into the report. In this part, the title announces pilotless planes are on the way. The armed forces are keen, the flying public less so. The armed forces are more interested in drone-like planes, and the public, the flying public, passengers, it will not be easy to convince them. So let's begin with the article. Last year, Boeing's Pilot Outlook report estimated that civil aviation will require 790,000 new commercial pilots over the next 2 decades. So, about 800,000 pilots. This amounts to about 40,000 per year. 40,000 new pilots per year around the world. Of those, 261,000 will be needed in Asia and 206,000 in North America. So a large chunk of these pilots are needed in Asia and North America. One approach to this problem, which is a problem, is to open more flight schools. An alternative is to need fewer pilots, and that requires better technology. So if I must paraphrase this first paragraph, it opens with the requirement of a large number of pilots. And of course, one can always open flight schools and train more pilots, but there is a technological solution to the problem as well. And that can also add more value when you remove the pilots and make the airplane fly with an autopilot. That can add more value to the flight in unexpected ways as well. But it can make it safer, for example, inputting more data, making the flight more a data-intensive process. And we can make use of the recent machine learning experiences as well, which we are going to discuss in the next part of the report. But when did this autopilot start? Well, it almost started with the first flight. The first autopilot was invented surprisingly early in the history of aviation in 1912, less than a decade after the Wright brothers' original flight in 1903. So this autopilot flight, it used a gyroscope and an altimeter to operate a plane's control surfaces to keep it flying straight and level. What's a gyroscope? What's an altimeter? That is a device that shows you the height at which your airplane is flying, and a gyroscope is basically a direction meter. It keeps track of the direction of your three-dimensional solid object in space. So have a look at what a gyroscope looks like on the Wikipedia. So stop the video here and do a little research about what a gyroscope is. It's basically a spinning ring that is used to keep the direction of an extended object. Okay, so the first autopilot used a gyroscope and an altimeter to operate a plane's control surfaces, like the ailerons, to keep it flying straight and level. Since then, autopilots have evolved into Since then, autopilots have evolved into flight management systems that can run almost every part of an airplane's journey except taxiing and takeoff, and even those are starting to come under automatic control. So, a flight management system, sometimes abbreviated as FMS, is the main software that controls almost all parts of an airplane's journey, except taxiing on the runway and takeoff. And even those are starting, the two, taxiing, takeoff, those are starting to come under automatic control. As recent events have shown, flight management systems are still not good enough to be trusted completely when lives are at stake. Of course, the reference here is to the 737 MAX aircraft accidents that occurred in late 2018 and March 2019. But in a world where automated drones such as America's Global Hawk reconnaissance vehicle routinely fly military missions without a pilot, it's a UAV, and self-driving vehicles are talked as if they were just around the corner, the question of how large a civilian flight crew needs to be is clearly open for debate. In other questions, do we really need two pilots on a commercial airliner? So at this point, let us do a quick review from our presentation. Okay, we are discussing avionics. We said pilotless planes are on the way. The armed forces are more interested, and it will be a little more difficult to convince the flying public. Here is a comic about working from home. This time the pilot is working from home, and the lady is answering a telephone call. Why? Yes, he is working from home today. Is that a problem? We see that it looks like a problem over there. Okay, so in the next 20 years, about 800,000 new pilots will be required, according to Boeing's pilot report. This is the person who invented the first autopilot, Lawrence Perry. So in 1912, his airplanes are much easier to control compared to the Wright brothers' original one, which the brothers tried to control it with their arms and legs, and that wasn't easy. He was flying the aircrafts lying on his stomach. And the flight didn't take, of course, a long time. We are talking about seconds and sometimes minutes. And this is what the cockpit of a modern airliner looks like. The question of pilotless planes is also relevant for the armed forces. In particular, pilotless aircraft can be sent on missions too dangerous for people, and possibly ones that piloted craft would be incapable of performing. For example, more than a 9G maneuver. The fighter pilots can sustain up to 9G, but not more than that, even if the plane is capable of doing that. So this could change how future wars are fought. Okay, let us continue. Both Airbus and Boeing are preparing for at least a single pilot commercial aviation world. Such a world will require not only reliable flight management systems, but also a redesign of the cockpit for one-person operation. Currently, there are two pilots flying an airliner. Both firms are now testing simulators of such cockpits. Airlines are keen. Why? Because it is cheaper to pay one pilot instead of two. A report published last year by UBS, a bank, suggested that moving to single pilot operation could save the world's civil aviation companies a $15 billion per year. $15 billion per year. Going fully pilotless would increase that figure to $35 billion. Of course, in that case, airlines. So there is a financial pressure for removing the pilots. I think that is the force that is going to make things move this side. It seems one of the pilots will be thrown out of the window. Moving to single pilot operation would require an aircraft's flight management system to be good enough to take over in a medical emergency that incapacitates the lone aircrew. In that case, the autopilot should be able to fly the plane to a nearby airport and land it safely. But this is already possible. For all practical purposes, that is true already. It is only during takeoff that the human touch is still widely regarded as necessary. On the other hand, pilots' unions say they are worried about the ability of a single pilot to handle an emergency brought about by a problem with the aircraft itself, such as an engine failure. It will be much more difficult for a single pilot to be able to deal with a problem of such gravity. But how necessary it is to have two crew members to deal with such exceptional circumstances, because they are exceptional circumstances, is moot. In other words, open to debate. It is uncertain. Okay. Okay, let's conclude this part by repeating the UBS report's claims. It says that world civil aviation companies will save 15 billion a year in total if they use one pilot for flights, and going fully pilotless would increase that savings to $35 billion. Okay. So this is quite a large number thinking about today's problems with the airliners. I think there will be some financial pressure on the airliner companies to go this way. But it won't be easy to convince the passengers to jump onto a pilotless plane. But the increasing number of drones and self-driving cars may have a positive effect on that feeling as well. Let's have a look at this in detail. Even so, automated flight systems are an area where the innate conservatism of aviation technology manifests itself. For example, flight control software for civil aviation cannot easily take advantage of the deep learning capabilities of artificial intelligence that is so popular today. The problem with deep learning systems is people don't really understand how these neural networks work. They do work, but it is not easy to understand how they actually work. Just like the human mind, it is not easy to understand how the human mind works. Regulators are loath to license anything they cannot understand. Regulators are not happy to license anything they cannot understand. They cannot fully understand. But the whole point of deep learning is that it reprograms itself in unpredictable ways in response to circumstances. That would be of huge benefit if for sorry that that would be of huge benefit, for it would permit the autopilots of individual planes to learn from each other's experiences, just like the self-driving cars. In civil aviation, then passenger aircraft are likely to remain twin-crewed machines for some time, but that may not be true of freighters, cargo airplanes. There would be no customer resistance here, either to single pilot operation or even to full dronification, as soon as that is possible. And if pilotless freighters prove safe, in a world in which self-driving cars had also been commonplace, passengers' attitudes might change as well. Okay, let's have a look at the defense side now. In America's armed forces, the next set of aircraft likely to drop its pilots is helicopters. Much of the work is being conducted under the aegis funding of the Defense Advanced Research Projects Agency, or DARPA, a research arm of America's Defense Department. This is the research agency of America's Defense Department. Internet is credited with DARPA. In other words, DARPA is said to invent the internet also. So that's a very influential agency. As part of its ALIAS Aircrew Labor in Cockpit Automation System project, the Sikorsky Aircraft Corporation, which is the helicopter division of Lockheed Martin, has refitted one of the firm's S-76B commercial models to be able to almost to pilot itself. So almost to pilot itself. Let me show you this helicopter quickly. So we are talking about this helicopter. For commercial use, Sikorsky has fully autopiloted this. As Chris Van Buiten, Vice President of Innovations at Sikorsky, so this person, Vice President responsible for innovations at the Sikorsky company, observes, flying a helicopter is far harder than flying a plane. Helicopters are aerodynamically unstable, so simply keeping them straight and level is a challenge. But the whole point of a helicopter is that it does not fly straight and level. It can dodge around to avoid obstacles, meaning it can hug the ground, all of which adds to the mental effort of controlling it. It's a difficult game to play, in other words, and it is often deployed in weather that would make a fixed-wing pilot think twice. Matrix, as the company names its experimental helicopter co-pilot, has a central processor that receives signals from a range of sensors and combines these with data from GPS and a map of the local terrain stored in its memory banks. So Matrix is the control software. It receives signals from sensors, combines them with GPS and with the local terrain map from its memory. The processor then sends appropriate signals to actuators located in various places around the craft's airframe to control its mechanical systems. The mission instructions themselves come from Matrix's human commander via a tablet computer, but Mr. Van Buiten hopes that voice recognition systems will soon become reliable enough for those instructions to be spoken. So the pilot, the human commander, sends the commands to the helicopter, and the helicopter automatically controls itself to do what the commander bids it to do. One of the advantages of Matrix is that it can respond much faster than a human pilot. This is valuable in normal circumstances. In an emergency, it may be crucial. It can, for example, react to an engine failure, assess a score of options for a forced landing, and recognize which is safest, all within 100th of a second. So it can react to an engine failure, assess a score of options for a forced landing, and recognize which is safest, all within 100th of a second. A human pilot would need a couple of seconds just to work out what was going on. So this is the value I was talking about at the beginning of the course. This is an added value. If you switch to autopilot, it can make your helicopter even more safer. This is the innovation part. One can be conservative and stick with the pilots and keep the things going as they are, or take risk, innovate, and see how that works. And it might come with some added value as such. The next step on its journey, which should happen in the autumn of 2019, is to test the system on Sikorsky's Black Hawk helicopter. So they will test the same system, the Matrix system, on Black Hawk last year autumn. I have a picture of and the video of Black Hawk controlled by the Matrix system on our presentation. So you can have a look at that. Here, it really will on many occasions be in sole charge. The Matrix system will be controlling the helicopter. Field commanders will, as Mr. Van Buiten puts it, have the option of 2, 1, or no human pilots on board. So this is the Sikorsky's S-76B commercial helicopter, and this is Black Hawk, fully controlled by the Matrix system. You can click the YouTube link here, and it will be really nice if you decide to have a look at Sikorsky's plans about vertical flight. I put another link over there.